In this section, we'll be talking about vector space. The term may sound unfamiliar to some of you. To give you a little hint before we go deeper, the reason why we talk about vector space is that vectors can be used to represent objects with features. And we want to treat each document, which is represented by the presence and absence of distinct terms, as a vector, so that we can put them into a space and calculate the distance between each of them. The object that a vector represents can be a document or something else. For example, we have three objects: rabbit, dog, and human. This is a very informal example, so please don't be too serious about the terminologies I'm using. Well, ones and zeros still mean presence and absence. If we define these three objects by only these three features, tail, coat, and sharp teeth, and represent them in vectors, the vectors of rabbit and dog will have a higher similarity score since they both get tail and coat present, although the rabbit vector doesn't have sharp teeth. Human is going to be somewhere far away as it doesn't have any of these features present. Just to be clear, the coat has nothing to do with the ones you purchase in the mall. So what is a vector? Vector and vector space are very closely related since a vector space is defined by vectors and the vectors exist in vector space. But because our teaching can only be linear, we have to talk about them one by one. A vector is a point in a vector space and has length from the origin to the point, and also direction. As a start, you may imagine a vector as a line which has direction and length. The truth is more complicated since a vector can exist in dimensions higher than 3, which we cannot imagine show in our three-dimensional world. However, the good news is vectors in higher dimensions will be treated very differently from the ones in a 2 or 3 dimension. And the work of calculation can be done by computers. It is meaningless to show a one-dimensional vector as it will be just a fixed point. Here are the examples showing a 2-dimensional and a 3-dimensional vectors. A 2-dimensional vector can be written as a bracket with 2 elements in it, while a 3-dimensional vectors can be written as a bracket with 3 elements. Now let's talk about vector space, the space that contains vectors. You may have already noticed the black arrows in the previous slides. It might be tempting to call them x, y, and z axes, but actually they are vectors as well. We call them basis vectors since they are the ones that define or form the basis of our vector space. The basis vectors are linearly independent and correspond to the dimensions or directions of the vector space. The basis vectors are linearly independent because knowing a vector's value along one dimension doesn't say anything about the value along another dimension. This will make more sense to you when you see an actual example. Let's take a look at our term document matrix again. As we mentioned before, we would like each of the document to be treated as a vector, and all of them should be put in one vector space for calculation and comparison. We need to be clear that vector space is very powerful. It can be applied in not only text mining, but also a lot of different fields. What is in common is that you have to define dimensions for your vector space, and the dimensions are determined by features. In this case, the terms are features. Our matrix has 7 terms, thus it defines a 7-dimensional vector space. Then these 10 vectors of our 10 documents will be put into the space. To make it official, let V denote the set of features in our feature representation. Any arbitrary instances can be represented as a vector in a V-dimensional space. In mathematics, the 2 short vertical lines denotes absolute value of V. For set, it denotes the cardinality of a set V, which means the number of the elements in a set. For simplicity, let's assume 3 features: breast, cancer, and Alzheimer. In other words, the cardinality of set V equals to 3. It's easy to visualize a three-dimensional space. Here we see the vector space representation on string breast, cancer, and Alzheimer with binary weights in which we only see ones and zeros. We will talk more about term weighting in later sections. The vector space is three-dimensional as there are only three features. In other words, three terms. And since all of the three terms are present in the document, the vector can be written as a set of triple one. Thus, in the three-dimensional vector space, it looks like this, the one showing on your screen. Let's add one more vector. The document of our second vector contains two terms only, breast and Alzheimer. Thus, in the vector space, a zero value of cancer leads it to be located at the plane composed of basis vectors of Alzheimer and breast. The third document contains Alzheimer and cancer. Similar to the second, its vector locates on the plane composed of the basis vectors of Alzheimer and cancer. Now you may see the reason why we are using a vector space to represent these documents. Instead of coordinate values, angle and distance can also be used to calculate the similarity of these documents. Now let's take a look at several questions.